In section 3.3, we will be using the concept of intercepts. Now, an intercept is a point, and it's a point where a line or any other graph intersects with the x-axis or y-axis. So we understand in football what an interception is. It's when two players are running and they end up at the same spot. Okay, so they are in the same spot and one of them gets the ball that the other one was supposed to get. But it basically has to do with them being at the same spot. So an intercept is a place where the graph of a line or the graph of any other graph will actually touch or cross the x-axis or y-axis. So our first exercise in this chapter is going to be to identify intercepts. So I want you to look at these graphs that appear on the page here. We have 6 of them, and we're going to look at each one and identify the x and y intercepts. Now remember, each x-intercept is a point. The point at which a line crosses the x-axis is a point, and every point has an x value and a y value. It has to be named as an ordered pair. So let's look at the first graph. At this this line right here. Okay, we want to identify the intercept. So we're going to look at the line that's graphed there, and we're going to find where it crosses the x-axis. And that is right here. That point is what we call the x-intercept. I'm going to abbreviate it. And that point is what? What do we call it? 2, 0. That is the x-intercept. We have identified it. Now, the same line also crosses or touches the y-axis. And where does it touch the y-axis? Right here, where that line touches the y-axis. So the y-intercept is the point 0 and -2. So we're going to look at all the rest of these graphs and identify the x and y intercepts. Okay? Look at number 2. The x-intercept is what? Is what point? 2 and 0. The y-intercept, y. The y-intercept is, let's see, right here. So that's 0 and 2. Okay? Remember, you have to name the x-coordinate and the y-coordinate. Every intercept is a point. So with number 3, the x-intercept is, it crosses the x-axis here. -1 and what? 0. It crosses the y-axis way down here at the bottom. Okay, so don't get confused about that. It does cross the y-axis. You just have to maybe think outside the box. So the y-axis, y-intercept is, let's see, 0 and -5. Okay, the x-intercept with number 4 is, where does it cross the x-axis? -3, 0. Y-axis, y-intercept 0, 2. Number 5, x-intercept is 1 and 0. Y-intercept 0 and -3. X-intercept number 6 is -4 and 0. The y-intercept is 0, -3. Now, one thing you should notice, the x-intercept always, that means always, has a y value of 0. Look at each one of the x-intercepts. X-intercept here, x-intercept, 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 x-intercept. All of them have y values that are 0. Okay? What that means is they lie on the x-axis because you're not moving up or down in the y direction. So it makes sense that it's a 0 in the y coordinate because you're not moving up or down. Now the y-intercept always has an x value of 0. X value of 0. The y-intercept has a 0 for the x value, 0 for the x, 0 for x, 0 for x, and 0 for x, 0 for x. Okay? It's important that you understand that x-intercept has a y value of 0, y-intercept has an x value of 0. Now here we want to identify the x and y intercepts when you're given a graph. So we're looking at where the graph crosses the x-axis and the y-axis. Now you have to use both coordinates for every point that you're identifying. So let's look at the first graph, number 1. It's a line. We want to see where does the line touch or cross the x-axis. It touches the x-axis here. And that point is the x-intercept is what? -4 and 0. Then the y-intercept is down here. That's where it's crossing the y-axis. That has the coordinates of what? 0 and -6. So those two points are the x-intercept and y-intercept respectively. Okay, now look at number 2. It's a parabola and there are 3 intercepts here. This parabola graph touches the x-axis in 2 places and the y-axis in 1 place. So we identify this point, and this point, and we have to name them. So this one is going to be an x-intercept at -2 and 0. This one is an x-intercept at +2 and 0. This one is a y-intercept at 0 and -3. All right, number 3. This graph only touches the x and y-axis both in one spot, and that's at the origin. So the origin here is the x-intercept. So it's 0, 0, and it is also the y-intercept. That's the only place where the x-intercept and y-intercept can be the same point, is at the origin. Now look at number 4. Number 4 only has one intercept. It doesn't intersect the x-axis at all. It only intersects the y at that point. So the y-intercept is 0 and 3. This one is an elliptical graph here. We have an intercept here, 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 and here. So you name them. I'm going to name this one 5 and 0, and this is an x-intercept. This one is another x-intercept. That one is -1 and 0. This one's a y-intercept, and it is 0 and 2. And this one's a y-intercept, and it is 0 and -2. Okay, so we've identified the intercepts. Now we're going to use intercepts to actually graph a linear equation. Now, to find the x-intercept given an equation, if you're given an equation and you're asked to find the intercepts, previously in the previous slides we were given a graph and asked to look at the graph and find the intercepts. But sometimes you will be given an equation, not a graph, and you will be expected to find the intercepts. And on a test, you will have to do it that way. Although there are other ways you could solve things, when you're asked a specific thing, you need to do it that way. So if I say, graph this equation by finding and plotting its intercepts, that's what you need to do. Now, to find the x-intercept, we're going to use the fact that y has to be 0. So you set the y value equal to 0 and then solve it for x. To find the y-intercept, every y-intercept has an x value of 0. I told you that in a previous slide. So we set the x value equal to 0 and solve for y. For instance, look at example 6. Graph the equation x minus 3y equals 6 by finding the x and y intercepts. Okay, so to find the x-intercept, we're going to let y equal 0. Because remember, the x-intercept has a y value of 0. We just need to find out what the x value is. So in that equation, the equation that's given is x minus 3y equals 6. So we say we let y equal 0. So if y is a 0, then we get x minus 3 times 0 equals 6. Then 3 times 0 is 0, so x minus 0 equals 6, or x equals 6. So the x value is going to be 6. So the x-intercept is 6 and 0. Now I'm going to plot that over on my coordinate plane. 6 and 0, right there. 6 and 0. Then I want to solve and find the y-intercept. So to find the y-intercept, I let x equal 0. So the equation is x minus 3y equals 6. But if x is 0, we have 0 minus 3y equals 6. Negative 3y equals 6. Divide by negative 3. So y equals -2. So our ordered pair is x is 0, y is -2. I want to make it a different color. Y is -2. So I'm going to plot this. 0 and -2 is down here. And so we can graph that line now by connecting and extending those 2 points. So we have 0 and -2. Let me graph it. And so here we have the graph. So it's obvious to me, and when I'm looking at test papers, I'm looking for the actual intercepts. Okay? When I say use the intercepts to graph, that's what I'll be looking for. Okay, we're going to graph x plus 2y equals -4 by finding and plotting intercepts. So to find the x-intercept, remember, we let y equal 0 because our point will have a 0 value, y value of 0. The y-intercept will have an x value of 0. So let's go back and let y equal 0 in our equation. Our equation is x plus 2y equals -4. So if y is 0, we have x plus 2 times 0 equals -4. But 2 times 0 is 0, so x plus 0 equals -4. X equals -4. That's our x coordinate for the x-intercept. The y-intercept, we're going to let x equal 0. So we have x plus 2y equals -4. X equals 0, so we have 0 plus 2y equals -4. So 2y equals -4. Divide both sides by 2. Y equals -2. That's our y coordinate of our y-intercept. So let's plot these points. -4 and 0 here. 0 and -2 here. Let me graph it. So here we have the graph of that line by plotting intercepts. Okay? This one we are going to graph by finding intercepts and a third point, a checkpoint. So let's find an x-intercept. To find the x-intercept, we let y equal 0. So the graph is 3x equals -5y plus 10. So if y is 0, then that whole -5y term goes away. So we have 3x equals 10. Now let me go ahead on and do it so you can, I can't undo this. I'm going to have to scratch it out. So we have 3x equals -5 times 0 plus 10. So then 3x equals 10. Divide by 3 on each side. X equals 10 over 3, which is 3 goes into that 3 times and a third. So the x value is 3 1/3, and y is 0. That's going to be the x-intercept. The y-intercept, we attain that by letting x equal 0. And our equation is 3x equals -5y plus 10. We're going to plug in a 0 for x. So we get 3 times 0 equals -5y plus 10. So that's 0 equals -5y plus 10. I'm going to subtract 10 from each side. So -5y equals -10 divided by 5 on each side. Y is 2. So our ordered pair is going to be 0 and 2 for our y-intercept. So now we're going to plot those 2 points. X-intercept is 3 1/3 and 0. So 3 1/3 is somewhere around here. 3 1/3 and 0. And then 0 and 2 is up here. Then it said we want to find a checkpoint. That means let's find another point. So to make sure that we did all our algebra correctly. Let's just choose one. Probably going to end up with some fractions, but let's just see a checkpoint. Let x equal, let's say 1. So then we have 3 times 1 equals -5y plus 10. So that's 3 equals -5y plus 10. Then we're going to subtract 10 from each side. So that's a -7 equals -5y. Divide by -5. So y equals 7/5, which is equal to 1 and 2/5. So our x is 1, y is 1 and 2/5. X is 1, 1 and 2/5 is somewhere around here. You know, it's not perfect, but it's close. And so here we have our graph of our line with our checkpoint there. Okay, so here we look at another example. Well, I want you to first see that we've learned 2 methods of graphing lines so far, by making a table of values and by plotting intercepts. In fact, when making a table of values, many times it is useful to plot the intercepts as 2 of your points. Either method is useful, but the more equations you graph, the more you will recognize which method is best for you to use at that time. Okay, our next topic in this section, we'll talk about graphing vertical and horizontal lines. I want you to look at this equation, x equals 2. And I want you to think about whether it's a linear equation in 2 variables. So remember what the criteria for a linear equation in 2 variables. Remember, it says if it can be written in this form, ax plus by equals c. Well, can x equals 2 be written in that form? Yeah, well, it can, because it can be written 1x plus 0y equals 2. The only criteria is that it can be written in this form. So anyway, this is a linear equation in 2 variables. It's just that the coefficient of the y variable is 0. So let's look at what this kind of equation looks like as a graph. If you make a table, such as the one that we have here, okay, look at the table and look at what happens if you plot some points. Let's say we have y. If we say y equals 3, look at the table and look at the equation, this equation right here. If y is 3, then what is x? x equals 2. If y is 0, then what is x? I'm going to write it again. X plus 0 times 0 equals 2. I'm just plugging in values of y to figure out what the x is. So x equals 2. So we have x equals 2 up here, x equals 2 here. What about when y is negative 3? We have x plus 0 times negative 3 equals 2. Well, x equals 2. So it looks like no matter what y is, no matter what the y value is of any point on this line, the x value equals 2. X equals 2 for every point on that particular line. What that means is the x coordinate is always going to be 2 along this line. Any point on a line that has the equation x equals 2 will have an x value that is equal to 2. And when you plot that, you get the points over here on this graph. You get 2, 3, 2, 0, 2, negative 3. And you can see that the equation x equals 2 is a vertical line that goes through the point on the x-axis where x equals 2. Okay? X equals 2 is always a vertical line. In fact, whenever you have x equals any constant, c means a constant. So x could be negative 3. X could be, negative 152. X can be 1,000. If it has the equation x equals a constant, it is going to be the graph. The graph will be a vertical line going through the x-axis at that point. Now, look at x equals negative 3. If you have trouble remembering that x equals 3, negative 3 is going to be a vertical line, then you plot some points. You say, okay, well, let me choose some points for y. And remember, this is an equation, x plus 0y equals negative 3. And if x and y are in your table, and you choose a point, if y is 0, then x is negative 3. If y is 2, then x is negative 3 because you're plugging in points for y. If y is negative 2, guess what x is? Negative 3, because that's what the equation says. X is negative 3. And if we plot those, we have negative 3 and 0, negative 3. Oh, no, that's not right. How did y'all let me do that? All right, negative 3 and 0, negative 3 and 2, negative 3 and negative 2. So it is a vertical line. I'm just going to wing this line. I'm not going to pull out my tool here, but I'm going to wing it. It's a vertical line going through the point where x equals negative 3. Okay, now, what do you think y equals a constant looks like? If x equals negative 2 is a vertical line, then y equals something must be a horizontal line. So what happens then? It means that y, in this case where we say graph, y equals negative 2, our x and y table looks like this. It means no matter what x is, y is 2. So if x is 2, then y is 2. If x is 0, y is 2. If x is negative 2, y is 2, because y is always 2 on this particular line. So let's plot these points, 2 and 2, 0 and 2, negative 2 and 2. See, it's a horizontal line. And then look at y equals negative 3. It's going to be a horizontal line going through the point on the y-axis where y equals negative 3. So if you want to make a table, it means no matter what x is, y is negative 3. So let's see, if x is 1, y is negative 3. If x is 0, y is negative 3. If x is negative 1, y is negative 3. So 1 and negative 3, 0 and negative 3, negative 1, negative 3 makes a horizontal line going through the point where y equals negative 3. Those are you will eventually recognize the graph. So whenever y equals a constant, any number, you have yourself a horizontal line. Okay, so you will have exercises to do in My Math Lab. Do those, and don't forget to turn it in assignments, and we'll move on to the next section.